YouTube, what the crap's going on? HeirofCarthage here, and thanks to my sponsor MSI, I'm going to be bringing you another build video here, giving you some good how-to information when it comes to building your own gaming computer. And today, it's going to be focused on the MAG Z490 Tomahawk motherboard from MSI. Again, they provided me with this motherboard, and last time I just did a build with it. It was an air-cooled build, pretty standard mid-tier gaming build. And today we're going to build a lot higher end machine, and I'm going to talk to you a little bit about how this motherboard can help you overclock your Intel K-series processors. Intel K-series, the K indicates the processor's unlocked, meaning that you can use your motherboard to feed it more voltage or use different settings to actually run the processor at a higher clock than is stated by the manufacturer. And that in turn can translate into higher performance either in your games or your different workload applications. And so again, the main purpose of this video, I will be doing a build step by step in the background. You're kind of seeing me do that here. But the main purpose of this video is when we get to the end to focus on using the overclocking abilities of the Z490 Tomahawk. So yes, very excited to show this to you all because I've overclocked processors quite a bit in the past. It's a lot of fun. It was something I knew nothing about and just spent some time watching YouTube, spent some time reading a few online articles, and you can learn enough to get started. And I really feel like MSI does a good job of making this as easy as it can be while still helping you be safe and making sure you're not going to ruin this new processor. So let's go ahead and talk about a couple of things here. First, can you kill your processor from overclocking it? Yes. Yes, you can. So should you do a little research before you do this? Yes. That's also why I'm doing a bit of a how-to video here. You can kill your processor in this process, all right? So be aware of that. Doesn't mean you're likely to kill your processor. No, if you pay attention and follow a few simple rules. And again, I feel like MSI in particular makes this really easy for someone who doesn't know a ton, and you'll get to see more about that later. As for now, I've installed the processor that we're going to be using for this video as the Intel i5-10600K, which is a 6-core, 12-thread processor, and the K, again, indicates it's unlocked. We're using 32 gigs of Corsair 3000 speed Vengeance Pro RGB, some very nice RAM, and then we're also going to be using the solid-state drive here you're seeing me install. This is just for the sake of getting you started on a build. This is a 500 gig solid-state drive from Silicon Power. I'll have a link to the parts list in the description if anybody wants to go through all these parts. This is not going to be a cheap computer or bottom end. This is going to be a high-performing machine. But you can still learn lessons from this. You don't necessarily have to build a super high-performing machine to do overclocks all the time. Again, I'm hoping that the lesson of this just kind of teaches you a little more about overclocking, and you can see how it may apply specifically to your machine or whether it can't apply. Now, the Z490, or the MAG Z490 Tomahawk has a lot of great features that I'm going to go ahead and mention while I'm installing it into the case here. We do need to move a few fans around. We're going to be having a large all-in-one water cooler up in the top of this case. And I am using the MSI Gungnir 100 case. Again, I'll have a link to all the parts in the description. You can go check it out. It comes pre-installed with a fan up top. We're going to move this and move it to the front to get extra airflow up front and to make room for a radiator in the top. Now again, this motherboard, why is it good for overclocking? Well, again, it has the appropriate chipset, which is the Z490 chipset, which for Intel, you have to have the Z designator in front of it to be able to overclock these unlocked chips. And this particular board, I think that some of the biggest selling features to me are the fact that the VRMs are very good, and then the cooling on the VRMs are very good. So the VRMs help deliver the power, and again, when you're overclocking, you may have to deliver excess power over the Intel spec. And then the heat sinks are going to help keep you from overheating anything on your board and help dissipate that heat. Not to mention MSI's BIOS makes overclocking very easy. We get two M.2 slots on this board, which is great for high-speed storage, like that you saw me installing previously. 4 DIMM slots, and it can handle up to very fast RAM. In this case, we're using 3000 speed. It can go faster than that. There's multiple SATA ports in case we wanted to add 2.5-inch solid-state drives or 3.5-inch spinning disk. It has 6 different system fan headers, a pump header, a CPU fan header. It's got 2 JRGB or addressable RGB headers on it, J-Rainbow. It's got standard RGB headers. This board is packed. It's got a ton of features. Anyway, that's one of the main reasons why we chose it. I'm going to actually start taking the case apart a little bit. You're going to see me doing some work here. I'm going to yank the case. Before you do any build, first of all, stop and think about what you're going to be doing. Measure out all the parts to make sure it's going to fit. I've already done this in this case, and I've also thought about how to best use the parts. Again, this case came with 2 fans installed in the front, one in the top and one in the rear, which is a pretty good setup, to be honest. But since I'm going to have 3 fans on an all-in-one water cooler on top, you're seeing me move that extra top fan to the front. It won't do a whole lot down here on the bottom because there's a power shroud in the way, or a power supply shroud, but an extra fan's an extra fan. I want to get all the circulation I can, especially if I plan to run a motherboard and processor hotter than usual. So yes, I want absolutely all the circulation I can get. The other thing, just to think about as you get a case, in this particular case, the fans actually came installed on the outside of the chassis. Here you can see I'm installing them on the inside of the chassis. If this is possible, you should do it, especially on a case like this that it's a solid front panel in front of the fans. There are vents cut into the side of it, but if your fan is too close to a front panel, there won't be any air for it to pull through. So by just moving these back inside the case by an extra inch or 2, that gives the fan a whole bunch of air in front of it to actually pull from, and it totally changed the airflow in this case. And it's extremely good airflow, actually, which is really cool because the front of the case looks very clean, having the mostly solid panel, but I still get the benefit of getting decent airflow. And again, when it comes to overclocking, make sure you have the airflow. If not, your case is going to be an absolute hot box. And what overclocking is, like I said earlier, just at a high level. I'm not going to get into in detail. I'm not a master, and if you know more about this than me, feel free to jump in the comments. But I'm essentially going to be feeding my processor more power than is recommended by the manufacturer. In so doing, that extra power is going to generate extra heat. The extra heat is either going to build up inside my case and cause things to chain and get worse, or I can remove that heat, and then I will be able to continue to keep my parts cool under long-term operation. So again, just want to make sure I'm very clear about why you should have good airflow and good cooling before you even entertain overclocking. Now, on top of that, there are a couple of ways to cool your processor. One is water cooling, and you're going to be able to see me just installing the motherboard here in the background. I'm not going to step-by-step these instructions. You can see it happening here. I've done other videos where I get more in depth on the step-by-step instructions, okay? But I want to talk specifically again about overclocking. Your processor has to have a cooler on it. In this particular video, I'm going to use an all-in-one water cooler, which means that I purchased the water cooler and the radiator, the pump, and all the tubes, and the fans. It's all part of one unit. I don't have to individually place and build them into the system, so I don't have to worry about whether I put a hose together right and caused a leak because of that, okay? So none of that is the case here. So I'm using an all-in-one water cooler because I personally like water coolers. They provide solid performance most of the time, and they look very clean inside of a build. You can overclock with an air cooler. It needs to be a very good one. One of the ones that I know right offhand, for instance, that usually can handle some overclocking is like a Noctua. I think it's a UD15, or I'll get the name wrong, but Noctua, for instance, makes a massive air cooler that can actually perform pretty much on the same level as a lot of water coolers. So you do not have to have a water cooler to overclock. It is common, and water coolers are good at it. And that's what I'm going to use in this video. But again, go do your research ahead of time on whether or not your cooler has enough thermal headroom to keep your processor cool, not only cool during stock operations, but if you go increase the juice to it, that it's also going to be able to keep up. MSI recently released their own series of water coolers. I actually went out and purchased this one. They did not necessarily provide this to me, but because I'm sponsored by them, I was curious about it. I went out and purchased this one because I do plan to use it in my own build after this. This is their Mag Core Liquid 360. This is a 360 millimeter radiator that has three 120 millimeter fans to keep it running. It is all RGB operation. You can see me kind of unboxing it here for you. This should be way more than enough cooler for this particular processor. I probably could have gotten away with a 240 or 280 millimeter cooler. In fact, I kind of like 280 millimeter coolers, just because the fans tend to run a little bit quieter and they're, still get really good cooling performance. But this one was unique because MSI actually stuck the pump in the radiator. You can see that square in the middle of the radiator that I'm pointing at. That's the pump, instead of being down in the head that attaches to the motherboard. So it's really cool. It's a nice feature, and then they also made a rotatable head on the pump, so you don't have to worry about how you mount it as much and having the logo still be right side up. So a small touch, but a nice touch to have. It comes with all kinds of stuff in here that we're going to need. These are basically all the different attachments depending on the CPU that we're using. This can work with most Intel and AMD processors, and that's why this package is just chock full of stuff. It's all the different attachments. So for instance, this is what we're going to need for attaching this to our Intel 1200 or LGA 1200 socket. We are compatible with that. And then when you get into these, make sure you get the instructions out. I'm showing it to you here. Read the instructions. It's important. If you do these wrong, it can make it where your computer doesn't want to boot or something overheats. Just take your time. Read the instructions. And then before time, see here where I'm showing you on the side of the box the different sockets that it supports. Before time, look all this up. Make sure it's going to fit in your case. Make sure it supports your socket, and so on. Take your time. Do the research. Because sometimes you can get these and it may not fit your socket or may not fit in your case. Now we're going to install the fans, and I'm going to show you here. With the fan, there's back braces. You can see those braces there. The fan pulls the air towards those braces. And in this case, I want the fan to be pushing air through my radiator. And so I'm going to get these fans aligned on the radiator, and I'm having to kind of, and I didn't show it on camera, but I stuck the radiator up in the computer, just held it there for a minute, just to understand, okay, I need to put my fans on this side. You can see I'm getting all the cords for the fans on the right side of the radiator, because you are going to have a lot of cords. There's 2 cords coming off each fan, one for the fan power and the other for the lighting. So take your time, get all this lined up, and make sure that you're doing, everything right. Then I have to get all the screws in here. Each fan has 4 screws. I do want to kind of go through this piece by piece. It's been a long time since I showed you all how to install an all-in-one liquid cooler. So I'm getting all of the fans attached to the radiator. First, I just kind of finger tight all of them, and you do so in kind of a crossing pattern. And then I'll come back with the screwdriver and then tighten all of them down again in a cross pattern, so that you get nice equal tension. You do want these fans to be very snug. You don't want to tighten it until you break the plastic on the end. So, do take it easy. You don't have to go that crazy, but you want the fans nice and snug. They have rubber pads on the outsides of each one. You want those to snug up to the radiator and create a nice connection so that you're not just bleeding pressure between the edge of the fan and the radiator. So there we go. I've got all the fans hooked up. The next step in this process is we have to install the right mounting equipment onto the back of the cold plate here. And in this case, if you look at the instructions, it says this little U-shaped piece here is the one that we shove on here, because this is the one that fits our Intel LGA 1200 socket that is on this motherboard. Again, you can look all this up off your motherboard, and you can look it up on the cooler site. So see, I just pop that on there. Now it has the screws in the right place, and we need to peel this plastic off of here so that it can actually make contact with the processor. And I'll show you more to how to install that later. I'm just going to give you an idea. This is the ceiling of our case, or the attic, if you will. You can see where the screw holes are up top that will fit fans or the radiators. Make sure you get a good look at this, and you kind of think about how to install it. Sometimes there's certain power plugs you want to plug in ahead of time, because you won't have much room once this thing goes in. And you'll have to think about, which side do I want my tubes on. For me, I need to have my tubes up towards the front of the case, because there just isn't enough room to have a rear exhaust fan and have my water tubes be in the back. Also, you saw those holes I was pointing to, and then I'm showing you up there where they fit. Now, let's take a break for a minute. Let's go to the power supply. Now, the one I've chosen for this build is the Cooler Master MasterWatt 750 bronze. This is a 80 plus bronze certification. This is a good, solid, kind of mid-range cooler. It's semi-modular, which means that keeping the cables clean will be pretty easy. And we have some expandability for the future. just what does the power supply do? The power supply is responsible for delivering power to all of your equipment. And if your power supply is not large enough, then you won't be able to run certain equipment. We're going to be overclocking a processor and having a rather beefy GPU in here. And then, like for instance, the new 3000 series cards from NVIDIA also use a ton of power. So power supply is very important in determining kind of how you can expand your computer and whether or not you can supply the power to it. The efficiency rating, in this case, bronze. Bronze is a nice rating to have on something. There's gold, platinum, titanium, all this other stuff too. The bronze rating is sufficient for most people and just means that it's a pretty efficient unit and it should be pretty reliable. You always want to look at reviews. You definitely want a reliable power supply. Power supplies that crap out can be very bad for your system, and so not a part that I would recommend cheaping out on if you were planning on doing overclocking especially. And you want to make sure you have plenty of capability. Now on the bottom of the power supply usually is a fan. This is going to pull cool air in and then eject it out the back. That fan needs to be, in this case, pointed down because you can see the ventilation on the bottom of the case where it's meant to draw in cool, fresh air. I like to plug in the cords that I'll need ahead of time. That's what you saw me doing there. I plugged in one for the graphics card, one for SATA power, and then one for the CPU power and the motherboard power already attached. And then you just have 4 screws in this particular case to screw this into the back of my case. While I'm doing that, again, let's just finish up with the power supply again. Don't cheap out on this. Do some research. Go out there. Look at the power rating on your processor and your graphics card. Make sure you have that much power. And then what I would do is get a whole bunch of action. You actually see my son playing with Legos in the background. That's perfect. So go make sure you get plenty of power. It's okay to have extra headroom in your power supply, especially if you intend to upgrade in the future or to do more overclocking. It's okay, to, like I said, to just have extra. Some people may say, oh, the 750 watts overkill. Well, that's okay. I'm all right with that. If you don't have the budget for it, that makes sense. Budget closer to what you want. But personally, I kind of like having plenty of extra juice. Then the power supply doesn't have to work very hard either. Doesn't have to run that fan as much. Hopefully it will last longer too because it's running less heat and not spinning its fan as much over the course of its life. But anyway, here we go. Power supply is installed and we're ready to continue our build. All right, here comes the part that no one likes in computer building, cable management. Everything looks so nice and clean right now because there's no cables plugged in. Nothing has power. None of the lights are plugged in. Just giving you a look at the inside of the case and what we've done so far. Looks very nice. Everything's looking very well situated. And like I said, very clean. We even have some pretty good color coordination going on right now with all the black and gray. I love that about this motherboard too. You can see where I've screwed the radiator, at least the first 2 screws. I just got them started. Sometimes you have to adjust things, so I haven't put all the screws in up top yet. Just a couple, like I said, in case I need to move it or I've miscalculated on something. Just don't get too ahead of yourself. But that's where we're at, and now we need to start plugging in all the cables, and I'll show you what that looks like. But first, let's get our water cooler mount set up. This is the Intel bracket that was provided in our Mag Core Liquid 360. Again, follow the instructions. This is what the instructions told me to do. I'm putting the pins through each of these holes in the right hole according to the size of my socket. And then they're going to have these plastic washers that kind of help hold these pins in place. And the pins are threaded on the end so that we can attach the CPU water block. Again, take your time. Look very closely at the instructions. So like, for instance, these plastic washers I'm putting on here. If you hadn't paid close attention to the instructions, you might have missed these. This thing installs on the back of your motherboard, and if you got any metal on metal contact because you didn't use these plastic washers, you could create a short on your motherboard, and you could really have a problem. And you don't want to do that. So again, take your time. Follow the instructions, especially if you're new to it. It's okay. Don't be one of those people that's like, oh, I must be a noob because I have to look at instructions. Everybody has to learn at some point, right? So again, take your time. And I took my time because this is a new cooler to me. I slowed down and I read the instructions even though I've installed a lot of water coolers. You're going to see the 4 holes here on an Intel motherboard, and that's what this is meant to line up with. You just shove that through, and now our mount is installed from the back side, and we're ready to go to the front side of the case and do a little work here. Here's what it looks like on the front side. We now have another kind of plastic insert here that we're going to take, and basically these help the cooler sit at the right distance away from the processor so that when you screw everything down, the mounting pressure is correct. So again, make sure you follow the instructions. We're going to push all these, one onto each of the 4 pins. And again, this will make sure that our gear from the water cooler is going to mount properly over the top of the processor. So I've got all 4 of these now into place, and we're ready to go ahead and move on and start to put the thermal paste on our processor and mount the water cooler. So take your thermal paste. On an Intel processor, something maybe just a hair bigger than a grain of rice is all you need. It'll spread out on its own. Just put something roughly the size of a grain of rice or pea right in the middle of your processor. So work just fine. I've done this a number of times. There are a lot of ways people like to do paste. I promise you this one works just fine. So I got that on there. I'm now going to get the head over here to mount this with. And now you can see that the screws that we now have are going to line up with the holes on the head here that we're mounting. And you just get it lined up to the right ones and kind of gently get it lined up. You don't want to smear your paste around until you're ready. And you're going to see here, I get it lined up slowly. And then once I do get it lined up, you'll see me put a little pressure down on it to kind of start smushing the paste out onto the heat spreader of the processor, which is that gray part on top of the processor that you've been seeing. Here's the mounting hardware I'm going to use, and I'm going to speed this up because it's just me putting on a screw. It's nothing special here. Again, cross-tighten them, and when you tighten the screws on the head of an all-in-one cooler or any CPU cooler, don't over-tighten it. Tighten it until it's done. These are always set up in a way to help you do that, and then stop. If you over-tighten it, you might warp your motherboard a little bit, which causes a short, and then your computer won't boot. I did that once. Don't do that. Do it right. All right, now I'm going to show you all the different plugs we had to put in. This is not easy. If you need to pause it, you can go back. I had to plug in audio plugs, fan plugs, RGB. I had to route the cables for my graphics card. This is the front panel connectors that you see down there in the bottom middle. USB 3.0 connector. This is my ATX motherboard power. Another fan connector, and then my CPU fan connector right there on top. And then I think I'm going to go to the left here in a minute and show you, over here, this is the CPU power connector. All of these things have to be plugged in. I don't have great filming equipment for getting you really good close-ups. I showed you what all I've plugged in. They only fit one way. Make sure you get them plugged in right. If you need a more detailed video, I'll see if I can find someone who does a good job with it. Now this case comes with an RGB hub, which is really helpful. I had 7 RGB lighting plugs that had to be plugged into it. And then the way I do cable management is I take my thickest cables right there, you can see, and I put them in the back, and then I can just run everything else along. And now remember, this side of the case is not visible. It gets covered with an aluminum panel. Just get stuff tucked away. See here, I use that extra space to push stuff out of the way. The disc cage I'm not using, you can push stuff out of the way. Use the Velcro ties they give you. Save any little twisty ties and all that kind of stuff. This side does not have to look pretty. This is the side you want to look pretty. And it does, because we took our time and tightened everything down in the back. Now we're going to install our graphics card. In order to do this, you're going to have to remove some screws at the back of your case to fit the size graphics card you have. I'm using here an MSI Ventus RTX 2080 Ti. So this, just maybe imagine that this is an RTX 3070 or something, right? In terms of performance, that's part of the reason why I used it in this build, because I know a lot of people are very interested in that 3070, even though it hasn't quite released yet while I'm filming this. Plug this down into your PCIe slot. You should hear a snap when it connects. Make sure it's firmly in there. And then at that point, you just need to put your screws back in order to make sure it's good and tight and it's not going to sag in the slot. And then you just plug in your power connectors. It's pretty simple to attach a GPU. It's one of the easiest things to do, in my opinion, in building a computer, other than just installing the RAM, which is also very easy. So I'm pretty proud of this. This build looks very good, looks very professional, except for that one cord I see sticking out back there. I noticed it after I built this, by the way, and fixed it, so don't worry, I didn't leave that fan cord sticking over there. But other than that, it looks very good and very clean. You can do this too on your own. This is a high-end computer we're building. This thing's no joke, right? This is a high-end computer. And again, you can do this in your own house with a little time, a little patience, and then fortunately, I have the benefit of some practice because I've built some before. I don't recommend something like this for your first build. You certainly can do it, but I wouldn't recommend it. On your first build, I'd do something a little simpler like air cooling, but this is for those of you who want to explore PC building a little more. And like I said, overclocking is one of those things that after I had gotten my feet wet and I did a build or two, as my processor started to age, I wanted to get more out of my already existing system. And that's one of the cool things you can do with overclocking. You can maybe keep your existing system going longer. It requires a little more investment up front to buy nicer parts and nicer processor, but you can do it. Is it necessary? No, you don't have to overclock a processor. Are you going to get like 50% more performance? No, absolutely not. Not unless you're breaking out something like liquid nitrogen, which is absolutely absurd and not for normal use, right? But what you can do is get some nice performance gains, and you can have some fun while doing it. So yeah, that's, again, part of the reason why I get into overclock. In case you need a good elbow view there too. I mean, that is one really good looking elbow. In any case, there we go. CPU is installed. That's it, folks. We just built a whole computer. It's not that hard. Again, you can do it. That's why I make these videos. I want you all to try it sometime. It's really satisfying. And it hasn't gotten less satisfying for me over time as I've done it. So here's a quick view of everything all put together. Very clean, very nice matching colors, black, white, and gray here. Just very, like I said, very satisfying. And here, when I fired it up, okay, I did put this thing on red alert. I've been watching a lot of Star Trek recently, so I decided a red alert theme would be really cool. Another fun thing about building your own computer, you can totally customize it for your experience. The bad news is the lights, they don't make your computer faster. Yeah, it's unfortunate, they don't. Turning my computer red did not make it faster. But it was fun, and it's one of those satisfying things for some people, and for me it is satisfying. So this is just also to show you the MSI, because of the different pins on this motherboard, I can support all these different products that light up, and I can control them from the software they give me. Now let's get into the overclocking. The first time you boot your computer, you're going to start pushing delete. It's going to bring you in here to BIOS. That's what you're looking at. BIOS is where you can control some of the hardware settings on your computer. You can see here our processor's installed, our RAM's installed. It's recognized. It shows you the temperature and how much over here up on this readout. So everything's working properly. I'm going to switch to the advanced mode here, and we're going to take care of a couple things. First, I'm going to click this XMP profile because our RAM was only running at 2133 megahertz when it should be running at 3000. So after I clicked XMP, I scroll down, and it now shows 3000 right here. So that's good. It's going to get us some extra speed that we should have. Our RAM just wasn't running at its speed. Sometimes it happens. I'm going to come over here and set my my CPU fan cooler to DC. This is just something I like to do with the water cooler. I let the pump run all out. That way it pumps plenty of water. The PWM and the smart fan mode just means it's going to increase the speed of the fan as it gets hotter a little more intelligently. Like I said, I just like my pump to run all out. And then this is just me adjusting the voltage going to all of my different fans. I think the radiator is hooked into System Fan 5, and then my front fans are in System Fan 6, and I think it's the rear fan that's in System Fan 2. I'm adjusting the voltage to all these. You can run them on PWM and Smart Fan, which again just means that the hotter your computer gets, the harder it ramps up. I usually just set them on something stable and quiet, but also effective. So you can see here, our base frequency, everything's operating the way Intel wants it to. Our base frequency is 4100 megahertz. We haven't applied any overclocking to the processor. We're going to exit here, and it's going to confirm all of our changes, and we're going to head into Windows. Sorry, there's a little bloom on the screen too. It's hard for me to record all this stuff. I'm doing my best with it. I think I'm able to improve it a little bit here and just. But yeah, it's the best I can do recording a screen with my phone. But in any case, we're going to pop into Windows. I also want you all to see the boot up time. When you use this SSD, so I just restarted it, and remember, it takes just a hair longer after you make a BIOS change for it to restart. That's why the screen's blank here for a second. But watch the boot up time. Here's the splash screen. This is why you use an SSD, folks. Watch how quick I get into Windows. Boom. In Windows. That quick. That is why you use a solid-state drive. Once we're into Windows, there's a couple programs you can download. I'll leave a link. One is called Hardware Monitor, and the other is called CPU-Z. I know, again, there's a little bit of bloom on the screen. I do believe I'm able to get it adjusted where you can see what's going on here. And if you have to, of course, you can blow this up to full screen where you can see better. Hardware Monitor lets me see the different voltages and temperatures and frequency at which my processor is operating. CPU-Z gives me a way to benchmark my processor. It shows you your operating frequency and your multiplier. So basically what it said there with the 48 is that the fastest we can go is 4800 megahertz. And then over here you can see what our temperatures are running. They're very under control right now. Thermal throttle on an Intel processor is around 100C. we were idling around 30 degrees C, which is very, very good. We're going to benchmark our CPU using CPU Z here. So I'm going to kick off a benchmark, and then here in a second, I'll just stick up a 10700 processor, which is a nicer processor than we have here, just to give you something to compare this one to. But this benchmark basically does one test where all of your cores are used 100%. That's the multi-thread. And then it does one where it uses one core at 100%. And it's giving you a single-threaded and a multi-threaded score. Single-threaded is good for certain types of stuff, and multi-threaded is good for certain types of stuff. You'd want to get as high a score as possible on both. On a multi-threaded score, remember that the number of cores you have plays in. So here the 10700, of course, is much better, and it beats us in the single thread as well. Remember our score here. We're at 514 on a single thread and just a hair under 4000 on the multi-thread test, okay? Also, the hardware monitor, we can see all the temperatures over here. Everything's just fine. This processor is behaving exactly like it should for a stock 10600K. Now let's go overclock. Now, of course, before we do that, though, I just want you to have noticed the temperatures, which I think you can see on that screen. We're well under control. We're nowhere near a thermal throttle, and that's what you want. You need that extra thermal headroom to be able to overclock. It is going to get hotter when you overclock, okay? Sorry for the focus and stuff here. Whenever you restart your computer, of course, this is with the cell phones, the autofocus is freaking out. Start pushing the delete key when the screen goes blank. That will get us back into BIOS. So that's what I'm doing right now, just pushing the delete key. And we're going to get ourselves right back into the BIOS where we can perform the overclock. That is where all of your overclocking is done. So here we are. We're back in BIOS. I'm going to click the overclock tab, and I'm going to do a very simple overclock. I'm just going to tell the computer to run at a higher ratio. I'm going to set it to 50. It was currently set to auto, which is 48. So this is a 5 gigahertz now because it goes in increments of 100 times 50. 5,000 megahertz or 5 gigahertz. I'm going to set this offset ratio to -2, which just helps a little bit with overheating when we're running certain instruction sets. That's all I'm going to change, folks. Now, there's a little bit of a silicon lottery here, as they call it. Some processors will do this very easy. Some will go even more than this. Some will go to 5.1, maybe 5.2. Some may have a hard time running at 5. It's just the lottery, the luck of what you get. And with this processor, I've set it to 50. I did already test this. It actually will work even at 5.1 or 51. It was a little hotter than I'd like, but anyway, we set it to 50. You got to give your motherboard a minute anytime you're implementing new settings. There are times when it won't boot because your setting won't work. You may have to clear your CMOS. I don't cover how to do that here, but basically it allows you to reset your motherboard to standard settings so that you can reboot your computer and you don't just get stuck again. But this worked, at least for now. We got into Windows. And once we boot into Windows, we're going to open those two pieces of software again, which is going to be our our hardware monitor. And we're also going to be opening our CPU Z. And we're just going to check that everything is running the way that we intended it to here. Meaning, are we running at 5 gigahertz as we set it? And then what did it do to our temperatures? Are we running too hot? Do we need to do anything about it? So we're going to open those programs and get CPU Z open. I got to close Steam because it's in the way. And then we're going to open our hardware monitor. And I'm actually going to open MSI Afterburner as well, which is another program I can use just to confirm that the temperatures are what I think they are. Now, you can see on the CPU Z, the multiplier is set to 50. And we are running at just about 5,000 megahertz right now. And that also shows up here on the hardware monitor. And then as far as the temperatures go up top, we're still completely under control while at idle. That's just idle though, right? We definitely need to test this overclock and see whether it's going to succeed. I'm going to start out by simply pulling up that same i7 processor again. And I'm going to hit our benchmark run. Look at that, folks. All the way up to 4,500 now on our multi-threaded score. That is a big increase. That is a 12.5% increase on our score there. So yeah, that's pretty awesome. So, and then look at the single thread. We've now surpassed the baseline 10700 processor. So by just doing a 200 megahertz overclock, that's only like a 4% increase. We've come up with over 10% increases in both single threaded and multi-threaded workloads. So again, this is going to just be giving us free performance. Now, What we need to do next is do what I like to call a burn-in run. We need to test this for a long period of times, and that's here on CPU Mark, or CPU-Z. I'm going to hit that stress CPU. This is going to run every core at 100% until I tell it to stop. I'm going to run this for at least 15 minutes just to see how my temperatures are. I recommend that you run this for almost an hour or more if you're going to actually use this overclock permanently. See if your computer crashes. See if it ever overheats. This is you just testing, okay? And keep an eye on it. If it starts to overheat, you want to stop it. And that's what you're seeing me doing here. And then I've got MSI Afterburner over here plotting my long-term temperature. Now, this is after 15 minutes, and you can see that temperature there. We've peaked out around, I think it's like 81 or 82 degrees. There are occasional peaks that bounce up to 85, but for the most part, our water's not getting any warmer here. This was in a 74 degree Fahrenheit room, or 23.3 Celsius. And then you can see that we peaked out at 82 degrees Celsius. So that's really not bad, considering that we have a heavily overclocked processor here, and that this is in a worst case scenario. Every core 100% maxed out for a long period of time. Now, how does this translate to gaming? Every game is going to be different. So what I did was I ran a Time Spy benchmark here on 3D Mark. And on the left is our computer that wasn't overclocked. And on the right-hand side is a score from the same computer that was overclocked. Look at that. We picked up 9.5% score on our CPU score and our CPU test, just from the overclock. And it rose our overall score from 12,599 to 13,034. And then you can see the difference here. It says last time we ran the test, our processor was running around 4,700 megahertz. Now it was running at 5,000 megahertz. And that's what did it. Again, this is very small. It's a small thing, but this gives you a boost in games, which translates to frames per second. So if you're wanting to get the most out of your performance, whether it's doing workloads like rendering video, or gaming, or whatever, overclocking is a viable way to do this, especially with Intel. Intel's a very good overclocker. AMD overclocks differently. It's also good at it. But in any case, I hope you all enjoyed this. I hope it was useful. If you have any questions, go hit me up in the chat. So here we've done it. We've built an overclocking monster with the Intel i5 10600K. I personally like Intel best for overclocking, even though my overall like right now is with AMD. But Intel is fantastic for overclocking. And they're a great gaming processor. And if you're interested in this kind of thing, the Z490 Mag Tomahawk, as I've proved to you here today, is great for building an overclocked gaming rig with the i5 10600K or any of the other Intel parts. Like I said, if you have any questions, hit me up in the chat. Thanks to MSI. Thank you all for watching. I will see you soon.